All right, so this is from page 55 and 56, question number 4. It says a flower pot falls from a windowsill 25 meters above the sidewalk. How fast is the flower pot moving when it strikes the ground? And how much time does a passerby on the sidewalk below have to move out of the way before the flower pot hits the ground? All right, well, let's just start with a little drawing here. So we'll put our flower pot on the windowsill. And the flower pot falls. And that distance is 25 meters. And I like to get a picture of what we're looking at first. Kind of helps me think about it. And then I need to know what is the question that I'm actually asked. So it's out, how fast is the flower pot moving when it strikes the ground? Well, this is one of those problems where something is um, implied for us. And because it's falling under the influence of gravity. So I know the acceleration of this object is equal to gravity is equal to 9.81 meters per second squared. I know that it falls a distance of 25.0 meters. Now, in some formulas, you might see that as a y because that represents vertical distance. Um, you also might see it as an h for height. We're just going to stick with d for right now. Okay, and we know that because it's accelerating, it's going to be changing speeds. So it's going to start here and it's going to pick up speed. So it's going to have an initial velocity when it starts of 0 meters per second. And the question was, what's the final velocity? And this question is usually easier if you have the time, but they're actually asking us for the time in part B. So we're going to have to find out what that final velocity is without time. At this point, what I would do is I'd look for the formula in my formula sheet, and you guys will probably find this one right here. And again, I like to have my formulas rearranged to solve for what I want already. All right, and I know that my flower pot was dropped from rest off the thing here. So my initial velocity is 0, which means this part of the formula is just going to go away. And I'm going to end up with VF equals the square root of 2 times A times D. Okay, so we'll just substitute in. Right, working across. So first of all, let's see what happens to the numbers. So I'll take 2 times 9.81 times 25. I get 490.5. And then I get meters times meters, which is meters squared over seconds squared. Take the square root of 490.5. 22.1, and the square root of meters squared over seconds squared is meters per second. And there is your answer.